All right, so here's your challenge problem to see if you can do your physics using only your models. Beware, there is a curveball in here. All right, so we got a scenario where a person's taking a trip, and whenever they're on the road, they go to constant speed. All right, they just put on the thing so it makes you go at the same speed. Except for they took a 22-minute rest stop. Wanted some sandwiches, maybe some panda, who knows? If over the course of the entire trip, the person's average speed was 77.8 kilometers per hour, how much time is spent on the trip and how far did the person travel? Okay, so there's two questions here and you have to answer them. Now, notice how everything's blocked out. I want you to give it a try and then I will come back and reveal the answers. So make sure you pause the video now and I'll be revealing them in 5, 4, 3, 2, and I hope you didn't cheat. You really should be doing this on your own because that's the whole point. But hey, here's your answers. So first of all, let's just nuke that. Boop. There's your time, and huzzah. There is your distance. It should say delta x there. My bad. All right, so time is about 2.8 hours, and the distance is about 218 kilometers. Now, if you'd like to know how to do that, well, my first hint to you is this. This is my velocity time graph. Now, the one thing that students have a hard time with us on here is they're like, I don't know, where do I put the 22-minute rest stop? You can technically put it wherever you want because they traveled at a constant speed whenever they were on the road. So to make your life easy, put it at the very end or at the very beginning, whatever makes you happy, okay? So if you do this, maybe that'll help you figure it out. So my recommendation is take a look at this, see if you can use this graph to make some solid math models and get those answers. Now, if you can't, that's fine. I will go to phase 2. So be warned. If you want to try it on your own, try again. Pause it, give it a shot. But if not, I'll reveal the next step in 5, 4, 3, 2, and done. So you can see I use that knowledge that the area is displacement. And so I looked at the area under each curve. So the blue is the overall average trip, which took the entire time. And the red is when they were on the road. That took the entire time minus the 22-minute rest stop, which, if you want to leave all your values the same, you have to change that into hours. So that's about 0.36 repeating hours. So don't put that 22 right there. That's the biggest mistake students make. Now, once you have this, it's basically just a lot of algebra because they're the same displacement. So, boop. Set them equal, do some algebra, you get your time. Once you get that, substitute your time back in to get your displacement. So I hope that worked for you, and I hope that that's allowed you to kind of gain a better perspective and see how you can manipulate a few things and the value in using a velocity time graph. All right, well, that's it. That's all I got. So I'll see you guys next time.